Once you've got a handle of first ionisation energies, successive ionisation energies are a little bit easier. Make sure you've written this out from last video, and then all you do is you just grab that one there and then repeat it to make it now for the second ionisation energy. You remove another mole of electrons, and then third ionisation energy, again just removing 1 mole of electrons. And so what actually happens here is the effective nuclear charge increases because the electrostatic difference just keeps on getting bigger and bigger each time you take 1 electron away. And so it just gets more and more difficult. But then as soon as you've taken so many that you've moved down to a lower sub-level or even worse, a shell, the electron's so much closer as well as having that electrostatic difference that there's a little jump for sublevels and a huge jump if it's moved down to a different shell as you keep on removing electrons away. So your job is just to work out from a successive ionization energy chart what the element is. And it's usually pretty obvious. If you look at the big jumps, you know they're the major shells. And if there's only 2 there, then that must be 1s. And you probably won't get the advantage of being able to see the enhanced version and even the little anomalies to give clues. But there'll be 8 electrons there, so that would make sense for a 2s and a 2p. But you're going to start here, and it's going to be 1, 2, 3, 4, 5, 6, 7. And so there's not quite enough here. So I would just generally count backwards here and do a 3s, and then you've got 1, 2, 3, 4, 5. So there would be a 3p5. And so if you look at your periodic table, so we're looking 1s2, 2s2, 2p6, 3s2, 3p5. That's chlorine. I'm sorry, I'm not looking at a periodic table right now, but I am looking at one, but you're not looking at one. Chlorine. It's also a little bit of a cheat also to just be able to count them. So it's 1, 2, should add up to 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17. Yeah, so there's 17 electrons, therefore 17 neutrons. And so the atomic number is 17. So there's a few cheats to this. That's why this is not that particularly difficult. But when you're answering a question, you're going to have to be very specific. So you need to say, well, the 3p5 electron was removed as the first ionization energy, and possibly write a few of these things out. So just be very specific. There's lots of clues to tell you that you're on the right track as long as you've given enough detail. All right, hope that's helpful.